Hello, this is Mrs. Poland for Algebra 2, Lesson 1.08 on Factoring Completely. This lesson is really a compilation of all different types of factoring where you do multiple types of factoring within one problem. Always start with the GCF. So we're going to start with example 7. So let me just make a wider screen. And let's get started here. So on number 7, we first look for a GCF, and we know 8 is in common to all three terms, 1, 2, 3, as well as x. So we factor out 8x from each. 16 divided by 8 is 2. X cubed divided by x is x squared. Negative 40 divided by 8 is minus 5. And x squared divided by x is x. 24 divided by 8 is minus 3. And x divided by x is 1. And then we look to see if we can factor further, and we have a trinomial here with the leading coefficient greater than 1. So in class, I had done trial and error, but you could have also done split the middle. So let me show you split the middle. So with split the middle, instead of finding two terms that multiply out to negative 3, what you do is you multiply the first and the last together. So 2 times negative 3 is negative 6, and we want it to add to that middle term still of negative 5. And we think of those factors, and those factors would be negative 6 and positive 1. And in essence, what we're doing is we're splitting up that middle term of negative 5x into negative 6x and 1x. So we're going to be literally splitting the middle. So I rewrite the GCF, and I'm going to put a bracket just so it's more clear on what we're distinguishing. A bracket and a parenthesis are the same thing. And so this becomes 2x squared minus 6x plus 1x, or x, minus 3. Could I have put the x first and switched the negative 6x afterwards? Yes, you'll get the same answer. So now what we actually did is formed a grouping problem where we're going to group the first two terms and the last two terms. So I bring down the 8x, and I notice that what's in common to the first group is 2x, and I'm left with x minus 3. For the second group, there's nothing in common other than 1, so we factor out the positive 1. And what we're left with is a common binomial of x minus 3, and we're going to factor that GCF out. I'm going to bring down that original 8x. Then I'm going to put that common binomial of x minus 3, and I'm left with 2x plus 1. And I just factored it. So in class, the only difference is I used a different technique to factor with a leading coefficient not equal to 1. Now let's go on to problem number 8. Remember, first thing you do is look for anything in common. And we know that there are no variables in common, but we know 3 is in common to both. So I'm going to factor out the 3, and I'm going to get 8x cubed plus 27y cubed. Well, that's a binomial now. It's not dots because we don't have a difference, and none of these terms are perfect squares. But notice that we have a plus sign in between the two terms. 8 is a perfect cube. 2 cubed is 8. X cubed is a perfect cube because the exponent is a multiple of 3. 27 is a perfect cube because 3 times 3 times 3 is 27. And y cubed is a perfect cube. So then what we can do is use the SOC formula. So the SOC formula is on the reference sheet. And the formula is a cubed plus b cubed, I'm just writing it down for ease of access, is equal to a minus b times a squared minus ab plus b squared. And so you're writing down that formula. In this case, a is the cube root of 8x cubed. Cube root of 8 is 2. Cube root of x cubed is x. B is going to be the cube root of 27y cubed, which is 3y. So now we're almost there. I know it seems like a lot, but we're almost there. I carry down that original 3 of GCF. It's a plus b. So a is 2x and b is 3y. Now I'm squaring the a. That's the next part of the formula. So 2x squared, that's what a squared is. So 2 times 2 is 4, and x times x is x squared. So this becomes 4x squared. We carry down the minus, and then it's a times b, so 2 times 3 is 6x times y. And then b squared is 3 squared. I'll just write it here. So b squared is 3y squared. So that's 3, well, I put the square in the wrong spot. Let's fix this. So 3 squared is 9, and y squared is y squared. And there we just factored this. If you factored out everything properly to the GCF from the beginning, this would be the final answer. And we're going to try one more together. And let's do problem number 9. So very first thing is the GCF. I know 2 is in common to all terms. I know x is common to all terms, so I factor it out. 2 divided by 2 is 1. X to the 4th divided by x is x cubed. 6 divided by 2 is 3. X cubed divided by x is x squared. Negative 18 divided by 2 is negative 9. X squared divided by x is x. 54 divided by 2 is negative 27, and x divided by x is 1. We have 4 terms, so what do? We group. We carry down that original GCF, and what is the common factor in the first 2 terms? X squared, and we're left with x plus 3. What's the GCF for the second group? Negative 9. Negative 9x divided by negative 9 is x. Negative 27 divided by negative 9 is positive 3. What is the common GCF? X plus 3. If I factor it out, I'm left with x squared minus 9. And then you say, oh, that's it, and that's not it. The first term's fine, it's prime. The second term's fine, it's prime, but x squared minus 9 can be factored further using dots. I hope this video was helpful, and I will see you tomorrow.